introduction. Let me just get quickly started. Yep. So hey guys, thanks for coming. First of all, I know this week has been really busy with a lot of assignments and midterms going on, but you guys made it. And me and Sahil hope that we do some justice to your time and give you a good brief about Python. Um, like Christian said, we would be dividing this session into 4 parts. The first would be like an introduction. Like it would basically focus on answering the question, what is Python, and is Python really right for you? Where is Python used in industries, in which fields, etc. And the second session would introduce you to Python syntax. Um, and the third session, we would get into a bit of coding. Um, and in the fourth session, we would kind of display a bit about our work, what me and Sahil, and how we like what we're doing in our thesis research and how we use Python um, in those. So with that, let's get started. Also just I just put some really good memes out there. And one very important motivation to learn Python is to really understand Python memes. Uh, because Python has such a large community, that means Python has a lot of memes on it. And there are some good memes. So if you get bored with me talking, just feel free to take a look at these memes. All right. Um, so first, what is Python? And Python was created by Guido van Rossum in 1991. He was a Dutch programmer, for which he was awarded the Benevolent Dictator of Life Award. So this award is pretty cool, and I really encourage you guys to look it up. Um, the second point has like some videos about him. These two are, the second one is like a session, and the first one is like an interview. These videos are helpful if you want to get an idea of what he was thinking while creating Python. What he was working on at that time, and how did he come up with this idea for Python, and why is it named Python, which is very strange. So getting into the definition, so Python is an object-oriented, high-level programming language with dynamic semantics. So let's break this definition into 3 parts. The first part is Python is object-oriented. So you'll notice in when we look into syntax and the coding sessions, that Python, the programming language, has some entities called as objects. Now these objects can store data and even manipulate them. And you'll see that whenever you have a problem and you want to write a Python script for it, uh, most of your code or most of your script will be oriented to around these objects, and hence it's object oriented. Uh, the second, it's high level programming language because it can't be it's not basically zeros and ones that can be easily understood by the machine. So it's a high level programming language with dynamic semantics. Now dynamic semantics is a very vague term, but you'll get more idea of it um, um, during during the syntax sessions. Um, so one a small part of this dynamic semantics is like in Python you don't have to declare variables, um, and that's really a blessing. So let's take a look at Python's popularity. So this is a plot from Stack Overflow, which shows the number of questions asked related to a programming language. And you can see that from 2012 to 2018, there has been an exponential growth in Python, which is a pretty good motivation um, to learn Python. And this is the future prediction. And actually, future is our current right now. I have not checked for 2020 values, but I'm hoping they're correct because many fields are accepting Python as their to-go language. And if not their to-go language, at least the second language after like, a faster programming language. We'll get to all of that. So let's take a little peek in some fields that actively use Python. Big data, obviously. You can imagine big data as like this table, a big table of data, and you have these columns, and you want to write Python scripts to kind of go through this data and extract data or create meaning out of it. Like for example, you have this company, and this company has this database about its employees. So the columns would basically be employee ID, employee name, years of experience in the company, and you just want to write a Python script. You just want to write you just want to find out all employees who have like more than 5 years of experience in this company. So what do? You go to Python and you write a script, and you can do all of that. Python is used in AI heavily uh, because of its amazing packages and very strong support community. Um, Python is used for software development, and let's talk about some very not like not the most common fields, but like Python is heavily used in automation. So suppose there is this process where you don't want human intervention, you can just write a Python script, and Python is heavily used for those purposes in industries. Um, Python is also Python is used in microcontrollers. So people who have experience with Raspberry Pi know that you kind of use Python as your controller, and even in Australia, like um, they've used these microcontrollers um, coded with Python or as is, in their street lamps. Um, so let's take a look at what companies think about Python. So Google has this famous quote saying that Python where we can and C++ where we must. Facebook and Microsoft actively research in AI. Facebook has launched this amazing Python package called PyTorch that everyone uses, and Microsoft uses Python heavily in their HoloLens applications. Robinhood, which is a California-based stocks company, really hires a lot of Python backend developers, uh, which is kind of surprising because you kind of don't use Java. I mean, you kind of use Java or C++ for software development, but Robinhood also prefers Python developers, and NASA is a great contributor to creating simulators, Python packages, and NASA heavily uses Python packages for data management and automation. And you can visit this link for more details about which fields use it and which companies use Python. And obviously, like we'll share these slides with you later on, and you can take a look. So let's get into what perks of Python are. So first, Python is easy to code. That was the main highlight. That is the main highlight of Python. And syntax is very similar to English. That means the only prerequisite you need to learn Python is English. You need to know English. Um, Python has great inbuilt data structures. Since it is very old, I mean, like Python was launched in 1991, it has a large support community, um, and has some great packages because it has such a large support community. So let's kind of discuss where you might not prefer Python. And okay, Python is slow, and we'll get into why Python is slow. And that's why it's not very advisable to use Python in heavy duty applications like if you want to build a simulator or you want to design your own game. You don't want to use Python there because it's not the most it's not the fastest programming language out there, and these things and the speed can really matter here. um, Also, Python, uh, if possible, should be avoided in real-time applications. Again, the factor is speed here. Uh, since Python has such great data structures and the syntax is very easy, um, when you learn programming in Python, you don't have any idea of what is happening at the computer memory level, which is like which is a bad point because then you can't be memory efficient because Python is doing all the things for you. And if you feel at some point that like no I you know I could have used the same memory block here instead of copying, and you'll get a better idea about this. I'm just thinking ahead of myself here, but yeah, you'll get a better idea of the why Python is very memory inefficient in the syntax and maybe in the coding also. um, so let's kind of get into it and how does Python go about executing a code. So I'm going to just give a high level picture. If you want to get into more depth, I encourage you to uh, take a look at the next slide. But basically what's happening is the source code is where you write your Python script. Um, this source code is then sent to a compiler where you can think of the compiler as a block that kind of does a syntax check. So whether your indents are correct, do you have colons placed at the right places? And the other thing that it does, which is very important, is it creates a workflow. Like, okay, this is the code that I've written, but this is the workflow of how it should actually work. Um, Basically, you can think of it of like a flow chart. Like, okay, this is process A, then after process A, do process B, and so on. And this compiler, this um, flowchart is actually called bytecode. Now, bytecode is low-level programming language, but it is not machine code. That means it can't be understood by the machine, and that's why you need an interpreter. And this bytecode is sent to the virtual machine, which is basically written in C code, in the programming language C, and this virtual machine kind of runs the bytecode. Um, so, so if I was programming in C, all I was doing was directly sending my code to the virtual machine without having a compiler and bytecode sections. Also, the virtual machine is not the most efficient way of running a code. So there are two places where you could actually increase your speed. One is direct. You could be here directly if you were in a programming language like C or C++, and you could write more efficient code in this part. Um, and these are the main two reasons why Python is really slow. And and um, uh, this is a bit of more information. I won't be getting into it because it has some terms like AST, which you might need to look up. But I encourage you guys to look at this Quora post, which is very informative of how things go about in Python. So let's kind of try and answer the question. So is Python really right for you? Um, so it kind of depends. If speed is really an issue in your project, in your thesis, or or like in your in any work that you plan to do, the first step I would recommend is kind of work on making the code more efficient. And if there is some time left, I can get into how we can make code more efficient in the fourth session, which is the coding session. And the first step is to make your code more efficient. And even then, if you think that maybe Python is still slow, then that makes sense to shift to a faster programming language. So let's look at some codes and some data from python.org. They say that where Python code is typically 3 to 5 times shorter than equivalent Java code, it is often 5 to 10 times shorter than equivalent C++ code. Um, Also, anecdotal evidence suggests that one Python programmer can finish in 2 months what two C++ programmers can't complete in a year. Now, I'm pretty sure that we are not doing such big projects, but still, you need to weigh um, the good and the bad, and then finally decide if Python is right for you. Another area that I forgot to kind of mention is where Python is heavily used is in academics. Um, so, so since Python syntax is so simple, you can kind of focus on your concepts rather than worrying about okay, how should I write the code. um, Basically, if you get your pseudocode ready, pseudocode is like, how do you plan to code. If you get your pseudocode ready, you can code it in Python. So that's why it's heavily used in academics as well. So with that, um, uh, I think, yeah, with that, we are done with the first part, which is about an introduction to Python, and we can jump into syntax.
Hi. So I think Christian just sent you guys a mail, which must contain like an IPython notebook. So could you guys like open it up and maybe open it in Colab? I think that will be easier. So Okay, I think many people might not be familiar with that, so let's just see how we can do that. Okay, I think so. So I think this was the latest mail which Christian sent you guys. So if you can go to the file, click on the file, and you should have a button on the top which says Open with Google Collaboratory. Click on it. So yeah, so this is the collab environment. Just let me know when you guys are when you guys have this open so that we can begin begin with the syntax session. Yeah, also you might want to open the Python version 2 file since the other one is like for the later parts where we'll be programming a bunch of things. Okay, so just let me know when you guys are done, like in the chat or like put a yes in the chat or something like that so that we can get started. Okay, Colin is done. Is anyone having like an issue with opening the collab notebook? Okay, Alrick's done. Okay. So this will just help you to follow along like easily. You don't really have to open it, but as I'm like going through the syntax, it'll be easier if you can like run things for yourself and see if things are working the way our intuition thinks like they're supposed to work. So I think learning syntax in any language comes with a lot of practice. So the point of uh, trying to explain the syntax of this language is to basically show the different functions and the methods which we have in this language, so that whenever you are trying to think of an algorithm, I just want to point you guys to some leads which you might find useful, like when you're trying to program things out. So essentially, like how do you convert your thoughts into code which you can execute? So okay, so let's begin with the syntax. So these are broadly the things which we'll be going over like in this session. But before we move on to anything else, I just want to lay a comparison backing some of the things which Alrick was mentioning earlier. So so printing things out of program is like one of the most basic things which we can do using any language. So let's try to see how what see the kind of code which we might have to write if we wanted to print a statement, something like hello world in Java. So we would begin with a class, and inside the class we would have a method which is called main. Inside the method we would have a function which is imported from a module, and in this function we give it the statement which we want to print, and then we'll also have to make sure about the indents and the brackets to make sure that the code is properly compiling. And after all these things are done, if you execute the code, you'll get an output which says hello world. But there are like so many unknown things and so many variables and words in this code, which makes it hard for beginners to learn things. So lucky for us, like we are not learning Java. And if you wanted to do the same thing like in Python, we would basically write print hello world, and that's it. It would be done. So so this is one of the reasons why Python is called an executable pseudocode, where the code basically looks like it's pseudocode, something which just comes out of your mind saying, okay, print me a statement like at this point, and it is executable since it completely works. So, so getting into the syntax, so the first thing which I want to show is that you use a hashtag or a pound sign to comment your code. So if you had a statement which said something like this, and you wanted to give this statement some description, you basically add a hashtag and then write whatever you want to describe the line. So this is really helpful when you're trying to get through complex code or you want to share your code with someone else. Sometimes this is really helpful when you're revisiting your own code and it's been a couple of months and you don't necessarily remember like the entire process which you took to write that part. So, so it is called as the executable pseudocode. And okay, now let's try to understand the concept of different variables in Python. So variables are essentially instances that can contain data. So the data might be integers or floating point numbers or booleans or strings or characters or a lot of other things. The really interesting thing about Python, which Alrick has mentioned like before, is that you don't have to declare variables like before you are using them. So in something like C, if you were to have a variable called A and assign a value of 1 to it, you would have to declare the variable that this variable A is an integer, which is denoted by int, and then you assign it a value of 1. Similarly, if you had a string called B, then you have to declare that B is a string, and then you assign the value of the string. However, in Python, like many things, it's really simple to do anything, and you don't have to declare variables like beforehand. You could just do A is equal to 1 and B is equal to Python or any other string, and that would essentially work. In Python, it is also really easy to denote complex numbers. So you just use the function called complex, and if you write something like C is equal to complex of 1 comma 3, that is essentially equivalent to saying C is equal to 1 plus 3j or 3i for engineers. So there are a lot of other different types of variables which you could have. As I was saying earlier, you could have integers or you could have floats. Floating point numbers basically have a decimal value added to the whole integer, or you could have the complex numbers as we've seen already. You could have characters, or you could have really big strings, or you could also have booleans. Booleans are not so intuitive to understand since they're not a part of the English language which we speak. So booleans are essentially binary values which represent the truth of a statement. So, so they can be written as C is equal to true or false with a capital T and an F. These are recognized keywords in the Python language. So if you had a statement which was something like 2 greater than 3, we know that the statement is false. So if we write print 2 greater than 3, it just returns a false value, a false boolean, denoting that the statement is false. Similarly, we could also have a true statement like 3 less than 9, and it would return a true value. So, so all the different functions which we have seen, like to print things. So we could print like the Boolean values of statements, and we could print the variable values of numbers and integers. It is really useful to know this shorthand trick with F. An easy way to remember it is basically you can do fancy printing with F. So if you had a string like B, you wanted to give this some context to what this means. So you could do something like print, take the string B is, and then add the value of the string B, and then add a dot. So when you print this statement, you essentially get B is, and the value of B would be substituted in this. And this would give you some context behind whatever you're printing. But this is a really long way to do it, and this is really annoying to have these plus symbols in front of the middle of the sentence and break the sentence into different parts. So an equivalent way to do the same thing, but a more elegant way to do it is basically use the F format. So using the F in front of any string enables the substitution of variables like into the statement. So you could have a statement which says B is B, where the other B is basically in curly brackets. So whenever there is a variable in curly brackets, this essentially means that this is not just a string. This is not just a character value which we have in this bracket. This means that the content of the curly bracket contains a variable. So since we know that B is already defined as mega, we just use the F and the curly brackets and then use a B to define it. We basically do the same thing as this one. We could do like much more complicated things by using B, where you could have multiple things, and it just streamlines the code like way better. It makes things much easier to read and debug. So the official meaning of F is that it refers to formatted string literals, where you can basically format the strings by adding variables which have their own values. So let's try to go over the operations that we have in Python. Like like most programming languages, we have the basic operations of addition, subtraction, multiplication, and division, which are represented by really intuitive symbols like plus, minus, star, and backslash or a slash. So in addition to the 4 basic operations, we also have the modulus operator. The modulus operator is represented by a percentage. This essentially returns the remainder which you get after dividing a number. As an example, if you had a number which was something like 26% and 5, which is basically doing the modulus, you know that it goes 5 times and you have a remainder of 1. So A is basically 1, and if you print the value of A, you can see that it is 1. So you also have another operator in Python called the floor division, which is denoted by 2 slashes instead of the single slash for a traditional division. So when you use the floor division, it only returns the integral part of the division and ignores the decimal part. So if you do something like this would return 5 and not 5 point something. So you could also have a shorthand notation for exponent. So C here basically means 2 power 10, which is written by double stars. Now let's go over a few comparison statements. The general intuition which we have holds really well when we are coding things up in Python. Like uh, like if we have a is equal to 1 and b is equal to 2, it's really intuitive to write the values of a is less than b, a is greater than b, or a is less than or equal to b, or greater than or equal to b. Like these are all valid symbols which do exactly what we think they'll do. As an example, we could see that if we have 1 and 2, and if we say a is less than b, we can test if this statement is true or false. And we know that it's true, so we can observe that it returns a true. I mean, just to be clear, like these are all executed statements. Like this is the code which we have, and if you just click on the top triangle thing, code basically executes and you get the outputs of these statements. So yeah, I'm sorry I didn't make that clear like before. You could also use shift and the enter button to execute a cell. And like notably in collab, like all the cells are interconnected, so you could have multiple cells which use each other's values or variables. So it's really intuitive using collab. And getting back to the different comparisons, we could also have the comparison for equality. This is slightly non-intuitive since usually whenever we are comparing things in mathematical sense, we just use a single is equal to symbol. But it should be noted that we already use the is equal to symbol for assigning values to variables. So, so we want to have something which is slightly different but still conveys the meaning. So we use a double is equal to symbol to use the equality condition. So since we know that A is 1 and B is 2, we can test if both A and B are equal by using the double equal to symbol, and if we print out the value, it just returns false. There are a few other different operations which we have in Python, which makes things more easier when you're programming like big pieces of code. So if you have a value of B, which is 1, let's print the value of B, it prints that it is 1, and you wanted to increase the value by 1 unit. So you just write B is equal to B plus 1, and you print the value and see that it returns 2. That makes sense. But there is a small shorthand which many programmers find it to be really useful when you are writing things. So this B is equal to B plus 1 is equivalent to writing B plus is equal to 1. This does the same thing because we are kind of repeating the same variable. So this is a shorthand for that. Similar to B plus is equal to 1, we also have similar notations for subtraction, multiplication, and division, which are also valid, where you can subtract the same variable by some value, or you can multiply it with something else. Now let's see a bunch of conditional statements. I think conditional statements are like the core of any programming language. They are the decision-making blocks of any code. So this is a small diagram which basically describes what happens in a decision-based block. So you have a Boolean expression, which might be true or it might be false. So if it is true, the code executes in one direction, it goes to another block, it executes these statements, and then continues. But if the Boolean statement is false, then it just goes forward without executing all these statements. As an example, we can have a really simple Boolean statement like 1 is equal to 1. We know that's true. So the decision making block is used by an if statement. So if something is true, then do this or something like that. So you have an if statement which basically asks you to evaluate the truth of the statement. And if it is true, then it goes on to execute this statement. So this works if there is a single line. But when you want to have multiple lines in your block of statements, you need to follow a notation of indentation, where you begin with your if statement, you write your Boolean expression, which is to be evaluated, and then you follow it by a colon, and then all the next statements, which essentially belong to a single block. So this single block is denoted by using the number of white spaces before that. So if you have a tab, uh, you need to have a tab and begin a statement and follow the same indentation. So all the lines which belong to this code should also be followed by the same number of spaces. I think this will be more clear when we go on to look at the bigger blocks which we have coming. And we could also execute code blocks in the else part. So if something is true, we could execute this code block, and if something is false, then it does not execute this part and goes to the else part. So if something is true, it goes to this, else it goes to the other part. So here we are basically saying that I'm giving you a true statement. So what would you execute? So since this statement is true, it goes to this block and it prints out code block 1. We just test it. So, and since this is true, it doesn't print this part. And these code blocks can get really complicated. And here essentially all these lines belong to the same code block. So all of them have equal number of spaces from the beginning, from the beginning where if started. So this has like 4 spaces, and then the second line would also have 4 spaces, and then the third line, and so on. So all the lines which have the same indentation are essentially a single code block, which will be evaluated using this Boolean statement. So just for the sake of completeness, if we had a false statement, instead of executing this part of the code, we would be executing this part of the code. That's it. So it is printing and not this. Now, let's go to the crux of using data structures and how you can handle data, like manage numerical simulations or a lot of other things. So the most popular data structure which is used in Python is the array. An array is basically a group of values. An array is a variable that basically contains a group of values. So we have an array called vals, and this array contains 4 integers. So to denote that this is an array, we use the square brackets, and all the elements are separated by using commas. That's a really intuitive notation. So if we print the array called vals, it just basically prints out all the values which are present in the array. Arrays come with a lot of properties in Python. So if you had something like, if you wanted to see the number of values which are present in an array, just say len brackets of array, and that's basically shorthand for length. It is showing an error since this code block hasn't been executed. So we should execute this one first and then execute this element. So we know that there are 4 elements, and it basically prints out that there are 4 elements. So there are many ways in which you can modify arrays and make them contain what you want to have. So if you had a small array called b, which basically had a single element which contains the number 10, if you say print b, it prints the value of b which contains 10. So if you wanted to have more elements in your array, this is how you would add an element. You would basically say b dot and append. Append literally means add something. So you just say b dot and append this value to my array. So it appends the value of 1 to b. And when you print B, it basically has both 10 and 1. In a similar fashion, you could also remove elements by using the remove function, which you can see, like you had B, which was 10 and 1, and then you removed 1, which is happened. You could also update array values, like instead of just adding or removing elements. So if you had an array which had like 1, 2, and 3, and you made a mistake and you want to change the value of 1 to a minus 10, you would just say a square brackets 0 is equal to minus 10. So let's think of what this actually means. So as I think this is one of the probably not intuitive things of Python, where counting things in Python begins with a 0. So if you had 3 elements, like you would count it from 0, 1, and 2. So like this, if you had 3 elements, so 1 is the 0th element, 2 is the first element, and 3 is the second. So if you wanted to change the first element, you would basically say a of 0 is equal to minus 10. It basically says that the first element needs to be changed to minus 10. As you can see, like before assigning that, it was 1, 2, and 3. And after assigning this, it was minus 10, 2, and 3. So let's explore like more properties of arrays, like where if a is equal to 1 and 2, and you had another array called b, which was also 1 and 2, if you just do a plus b, it, like intuitively we might be thinking that the elements would be added element wise, like 1 would be added to 1 and 2 would be added to 2, and we would get like 2 and 4 or something like that. But in Python, when you mean like a plus b, it basically adds the elements together. It's inspired by set theory, where I think just group elements or something. It also contains repeating elements. So how do we do what we really want to do? How do we do like element wise adding things? This is a much more complicated task than the intuitive thing which we can see. This is essentially saying take the first element of A and the first element of B and then add them together and put them as the first element of C. But it's just written in a convoluted manner. But we will revisit this concept when we are learning about Numpy, which Numpy is a really interesting Python module which lets you do a lot of uh, intuitive things without programming them by yourself. So we'll definitely come back and see how we can intuitively add two different lists. Let's explore another data structure called dictionary. Uh, so in arrays where you could basically refer to elements by their positions in the array. So you could have a of 0 is equal to something and a of 1 is equal to something and a of 2 is equal to something else. In a dictionary, you could refer to elements not just by their positions, but literally by using anything you want, which is really counterintuitive if you listen to it for the first time. But you could have so a dictionary is basically represented by two curly brackets, and you could have a of m as something. If we were to calculate the force of something of a physics problem, we could store the mass in a dictionary as a of m. M is basically some string, and you could assign it some value of 2, and you could give it another character called a for the acceleration, and let's just make it 10. If you wanted to calculate the force, you could basically say, okay, from my dictionary A, like bring out my value of M and also bring out my value of A, and then multiply them together. In hindsight, I should have made this variable something other than A, since we are using A for acceleration, but I think you get the whole. So when we simply print A, which is the dictionary, we can see that it contains a lot of different variables. It shows that there is an M which contains a value of 2. So it is separated by a comma. And you can see that there is a character called A whose value is 10. And you could also see that there's a character called F whose value is 20. So dictionaries are really useful when you're trying to store data structures which are of different types. These are more flexible than arrays. So in order to test the kind of leads which you get from a dictionary, you could just say a dot keys. Keys are basically the values which are substituted for the indices. So here the keys would be M, F, and A. And these values are called values. So these are the keys and values in dictionary. So we also have sets in Python. So sets basically just contain a group of numbers without any order. So in an array, if you had an array like this and you were to say arrays are represented by square brackets and sets are represented by curly brackets. So if you said a of 0, it would be 1. But if it's a set, then there's no meaning behind saying the first element of a set. So if you were to print the first element of this set called a, it would just return an error. We also have tuples in Python, tuples. So these are basically immutable lists where you could have a definite value. So here a contains, so tuples are represented by these regular brackets, unlike arrays which are represented by square brackets and sets which are represented by curly brackets. So if you were to assign a new value to this number, it would be impossible to do it using a tuple. So if you were to have a value which was standard like throughout the code, and you wanted to make sure that this value wasn't changed or modified through some other action, it will be a great idea to put your values using a tuple. This will make sure that these values remain what you initially assigned them and don't get modified in the future. You could use the del function to uh, remove the context of a variable from the code. So if you have a variable a and then you just say del space a, the value would just be removed from the method. And if you were to print the deleted variable again, then it would just return an error since a is not defined anymore. Now let's try to understand loops. Loops are really important. They help us to automate tasks and do a bunch of things like many times. Uh, so let's begin with a small array called 1, 2, and 3, and let's see how we can loop over all these values and keep printing all of them. So if we had like, so this is another method to initialize an array. So you could directly write like 1, 2, and 3, or you could say initialize an array in the first 5 integers. So give me a range of integers from 0 to 5. So that's what is represented by this. So so I think the takeaway from this is to essentially see that nums is basically 0, 1, 2, 3, 4, 5. And now let's see the for loop. The for loop is essentially used to loop over all the elements of an array. So you just say for num in nums, where nums is basically 0, 1, 2, 3, and 4. You just say for num in nums, for a number in the number array, and you give a colon, and then you again follow the indentation uh, rules which we are following in the if and the else blocks, and we just say print the number. So just to understand like what's happening inside this for loop, we just say after every time this code block is done with execution, we just say print iteration done. It means that the code block has been executed once. So the first time the code block is executed, the value of num is 0. Second time it's 1. third time it's 2, and so on. Because the first time it goes over like the first value of num, and the second time it goes over the second value of num, and so on. So that's how you go like all the values in your array, and you could do like a lot of complicated operations and not just print the values. So another easy way to loop over a range of values is to simply use the range command, where by using for I in range 10 to 20, you could basically loop over all the values in the range 10 to 20. So when you say for I in range 10 to 20, you just write print the value of I, it just returns 10, 11, 12, and so on and so forth. So if you wanted to stop in the middle of your loop by using some conditional statement, you could do it using a break statement. So if you are looping over a range of numbers from 90 to 100, and you're checking them using the print function, and you're printing the numbers, you want it to stop after 95. So if the values in the loop are greater than 95, you just say values are greater than 95 and then break. So as we can see, since the loop is expected to go from 90 to 100, like right after it hits the 95 mark, it just prints that the values are greater than 95, and then the loop stops. So this is an interesting method available to check if the break part of a code has been executed just by using an else at the end. It is very similar to the if else construction, where the first part is basically an if. If something breaks, then it will not go to this, but if something doesn't break, it goes to the else part and prints that it did not break. So here we are looping over 90 to 100, and we have a break checking if values are greater than 105. Since these are only less than 100, the break part would not be executed. So it just goes to the else part and prints that it is equivalent to a for loop. We also have the while loop, where it basically does the same thing as a for, but it's just a more convenient way to do it. And in the while loop, you could also have the break statement with a similar functionality as the for loop. Now, let's try to see how we can write custom functions in Python. So far we've been using pre-built, predefined functions in Python like print or the arrays, or so how do we write like functions which do specifically what we want them to do? So here I wrote a small function to add two numbers, which is a really silly function, but it gets the job done to explain things simply. So every function begins with the keyword def, which basically means that you are defining this function. And next we write the name of the function. So we write add nums, and next we have two brackets which contain the arguments which we want to give into the function. So since the arguments to the add function might be the numbers which we want to add, we just say we want to have two variables, that will be a and b, and then we end it with a column. Again, since we are writing a new code block, we begin with the same indentation rules which we've seen earlier, and we have a new variable c, which basically adds a and b, and it prints the value of c, and there is a statement at the end which is called return c. The function of return is to essentially return the output. So when we call this function, this whole code block is executed, and the function throws the value of c out. So if we had add nums and 2 comma 1, it basically returns 3. 2 plus 1 is 3. So we'll be doing like more examples from the coding exercise to use a lot of functions to get a grip on how we can write like much more complicated functions next session. So Numpy is a really useful Python module, especially for mechanical engineers who are working on numerical simulations or matrix multiplication. Numpy is the closest thing which will get Python to MATLAB. So using Numpy, we can do a lot of MATLAB resembling functions. Numpy basically translates to numerical Python. So let's begin by how we can import a new module. A module essentially contains a lot of functions which we don't have to write by ourselves, and we can just import the module and then use all the functions which come with this module. So if we write import numpy, that's it. We can import all the functions which are available in the numpy module and then use them for our own code. So if we had a is equal to 1 and b is equal to 1 and we wanted to add them, this is really redundant, but I just want to do this to show the functionality. So we could write like numpy.add, and this basically means from this module numpy, there is a function called add. Use this function and put in my variables a and b, and then we see the value of c. There are like a lot of complicated functions than a simple add in numpy, which I think will be really useful to. And so instead of writing the module's name at every line, which we hope to use this module, we could use a shorthand for this. So if we write import numpy as np, so instead of using c is equal to numpy.add, we can just say np.add, since we have imported numpy as np. And I guess this adds on to the executable pseudocode part, where this is how you would talk when you were to say that, okay, import this module as something. So as I've talked before, so if you had two arrays and you wanted to do the element-wise addition, you basically say numpy.add a and b, and this would give you the element-wise addition. There are also a lot of different functions which we can do in numpy. You could do element-wise addition or element-wise multiplication or division, which are really intuitive, and this is what we might be doing if this is what happens in MATLAB. And numpy functions are really useful for a lot of matrix multiplications. So this is how you would write a unity matrix of 3 by 3 size. You just say numpy.ones and you would get a unity matrix, and you could have a zero matrix with numpy.zeros, and you could have an identity matrix with numpy.I, the size 3. So this is what you get. And you could do element-wise multiplication by directly multiplying them, or you could do the matrix multiplication by using the matmul function. So if you had A and C, which are two matrices, something like this, then by using numpy.matmul, which is basically matrix multiplication, you get the matrix multiplication as well. You could also do an inverse using numpy by using the linalg module within the numpy. This is basically the linear algebra supporting module, and in this module you have the inv function, the inverse function, which lets you invert a matrix. So in Python you also have a lot of tools to plot different functions. So if you begin with a list of values from 0 to 9, you square those values, you basically import a new module called matplotlib.pyplot and import this as plt. Since this is really hard to write at every line of your code whenever you are using this, then you just say plt.plot a comma b, where a represents the x values and b represents the y values. So this just gives you a plot of the x versus the x. x versus y. And you could have like plots which can be used in your publications, because all the titles basically support the LaTeX commands. So if you can have like a summation, or you could have the degree Celsius in your labels. You should definitely check these functions out if you are into using Python for your plots, for your papers. You could also visualize matrices by using the plt.image show function, where this is an identity matrix. So whenever you get stuck with using some function and you don't know its functionality, you could use the help function in Python to basically see what it does and a couple of examples. So if you were to type like help numpy.sum and then run it, it basically executes. And okay, so we haven't imported numpy here. Yeah, it says that okay, np.sum, it's basically the cumulative sum of arrays, or you could have a couple of examples where you could do np.sum 0, 1 and 0, 1,5. This would give 2.0 and so on. I think since you've learned a lot of syntax like this in this session, so it'll be really useful to go over a couple of examples using all the syntax which you've learned so far. So I think Alrick will take over, and he'll go over a bunch of problems which might be interesting to see using all the syntax which you've just learned.
Hey guys, I know you guys have just seen syntax, but let's get into a bit of coding, and let's try to solve some so-called easy problems. And if there's more time, I can also introduce some methods in which how we were discussing the Python is really slow, but like we could discuss ways to overcome that, and that's if time permits. Otherwise, all the code is already there in this, and you guys can definitely take a look at those questions. So let's get started. Um, just a sec. Okay, yeah. So uh, let's get started with the first problem. And the first question is, we want to know whether a number is prime or composite. That's as simple as it comes. So for example, if n is 10, we want a function to output composite. I mean, like the number is composite. Um, so as I said that it's a good practice to kind of um, think over and brainstorm. Okay, like before you start coding, it's like, okay, how do I want to approach this problem? And let's 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 go. And I mean, this is what I came up with. Obviously, there are many ways to go about this, but um, so what we can do is check for all values less than n if they're I mean, like for like I have to check whether 10 is divisible by any number from 9 to 2, right? That's how I know that it's either prime or composite. So if it's divisible by even one of those numbers, it is composite, else it's prime, right? And then second step, what we're going to do is we're going to check for special conditions. Like what if someone like inputs a number like -1 or 1? So we will also try to take care of those conditions, and let's check. Like for example, if n is 10, we need to check whether it's divisible by 9, 8, 7, 6, 5, 4, 3, 2. And if it's divisible by any of those numbers in the set, then 10 is composite, else it's prime. So let's get onto the coding. So one thing you'll notice is that the way Sahil has defined his functions and I defined, and the way I use print and the way I code is unique from people to people, and it's really recommended that you develop your own style. And so there is no correct way. There is just the one that's one is which is most comfortable to you. Okay, so let's get into the function. So I'm defining a function called is prime. Um, the function is, uh, so let's see what the function is going to do. And you can see in these comments that n is supposed to be an integer greater than equal to 2. The function is supposed to verify if the input integer n is prime or not. And it is going to return a boolean. And you guys saw in the syntax that a boolean is nothing but a true or false value. So first let's take care of the special conditions and get them out of the way, right? So we're going to check if n is 1, and we know that 1 is neither prime nor composite, and we're going to print that, and we're going to exit. Now, if you want to exit code in Python, you can do that using exit, and you can just put any number here, like 1, like 2 or 10, anything. But exit 0 is kind of used very commonly. Next thing, let's check if n is less than 1. So if n is less than 1, we're going to use the keyword called raise to raise an exception, and we're going to say that okay, this number that you've given is invalid. And once you're done with the special cases, we're going to jump to the actual counting. So what we're going to do is we're going to loop over 2 to n. Now remember the uh, whenever you give it two values, suppose range of a to b, the range would be inclusive of a, which is the lower limit, but it would not include b, which is the upper limit. So if I write this as 2 to 10, range of 2 to 10, it would be 2, 3, 4, 5, 6, 7, 8, and 9. It would not include 10. So what we're going to test is we're going to use the modulus operator to check if the remainder is 0 for any of these numbers. So we're going to divide n by all of these i's, and we're going to check whether the remainder is 0 for any of these. Because if the remainder is 0, that means the number is divisible by. And if so, we're going to directly return false. We are not going to worry about lower numbers. We're just going to say, okay, it's divisible by this number, so it has to be prime. So we're going to return false. So kind of let's test this code for a lot of for some cases, and these are the cases. So as you can see, there's 2, 3, 10, 11, 23, 99, 999, some random number, 1 and 23. So as you can see, this is the value, and this is printing whether it's prime. 2, 3, yeah, 10, no, 11, yes, and so on. um, so this is a basic introduction of how we can use how can we define a function, which is a Python object, to solve a problem of finding whether the number is prime or composite. And as you can see, the syntax is pretty much English, where diff stands for define. Is prime is just like the function name, and yeah, so return means you're returning a value, and the syntax is pretty much English. So yeah, I would say don't kind of focus on a lot of what these terms mean. These are just to make the print look pretty, but that's it. And So with that, now let's move on to the second question, where I would kind of ask you guys to give me some feedback on, ask you guys to share your thoughts. And the second problem is like, we're going to check whether two strings are anagrams of each other. And what does that mean is that two strings are anagrams of each other if characters of string 1 can be interchanged to form the second character. So let's look at some examples. For example, let's string 1 be s1, string 2 be s2, and s1 is given by AA, BBB, and AA, and s2 is given by ABB, AABA. So as you can kind of work it out in your mind, rearranging the characters of s1 would actually result in s2. So the function output would, yeah, they are anagrams. And example 2, we have ABCD, and the next string is BCDAA, and as you can see that there's one extra A here. So this string can never be interchanged in a way such that it becomes BCDAA. The max it could do is it could form BCDA, but there's one missing A, so they are not anagrams. Now, I was thinking if you could take some time out, like a minute or two, and feel free to unmute and give me a suggestion of how do you think we should approach this problem. This might not seem very intuitive, but just any solution is fine. Even if you think it's wrong, yeah, just feel free to suggest and unmute yourself and suggest something. Mhm. The way that yeah, go ahead.
I could try.
Yeah, go ahead.
So
Yeah,
we're trying to check if they're anagrams of each other. So just thinking out loud, you could probably take one of the strings and mirror it, and
yeah.
then go through a loop that that checks equality between each of the items in the string.
Okay. I think instead of mirror, you meant like just permute it, right?
Yes.
Yeah, because yeah, that's actually the first thought that comes. It's like, okay, so if S1 and S2 are anagrams, so I should kind of get all the permutations of string one and compare it with string two. That's actually the first thought that comes to mind. Okay, so any other suggestions, or we could kind of move ahead, because that is basically my method one. So yeah, so Christian kind of got it. Um, so any other suggestions, or else we could move ahead.
Hi.
Hey.
I'm thinking if it's possible that if like doing a like counting how many characters, like if it's show up A and then store it in like something like a buffer, and then 2A's are counted as 2, and then if there's like next character is different, and then so it would just like store at like maybe like buffer 2, and then just like count through it. Like is it possible to like store in like separately like how many A's and B's or C, and then compare to like string 2 like how many of them, and then do like doing the output.
Yeah, that's actually, yeah, that you are actually correct. Yeah, you actually suggested a very good method actually. So so let's get into it. So both my methods are out, and basically I don't have anything new to give to you. But okay, so method one was what Christian suggested. Oh, by the way, thank you, Amy. That was a really good suggestion, and thank you, Christian, as well. So method one is basically what Christian suggested, that you get all the permutations of S1 and compare each with S2. Um, the second suggestion is what Amy suggested, is that S1 and S2 can only be anagrams if they have exactly the same characters. That what I mean by that is that if you look at the first example, is there are 4 A's and there are 3 B's. And similarly in S2, there are 4 A's and there are 3 B's. And that's the only way that they can be anagrams if the number of characters and the frequency of characters match. Um, for example 2, you can see that there's an extra A, so they can never be anagrams. So basically what we need to do is we just need to count the number of occurrences um, of A's and B's and all the different characters and just match it with the other string. Um, but like there's also another way to do it, and that is sorting. So it is kind of weird to think about, okay, how do you sort strings, right? They are just alphabets. But as you guys know that every character in coding is associated with the number. So So A would have a number associated with it, B would have an associated number with it, and according to the ASCII system, um, A is less than B, and capital A is greater than small a, and so on. So when I sort string S1, um, I should get something like A, B, B, B. And when I sort string S2, I should get something like A, and B, B, B. So basically what I want to do is I want to sort both strings and then just compare them. And if they are the same, that means they are anagrams, or else they are not. And let's just go over the code. So I'm defining a function called R anagrams. I'm taking two strings as inputs, and I'm going to return true if they are anagrams, else I'm going to return false. So first, we're going to use the keyword called sorted. So this is a very handy keyword. So sorted kind of sorts. Um, it sorts strings, it sorts lists. It can pretty much sort a lot of data structures. And so you sort your S1, you're sorting S2, and then you're just going to compare them. So you say that if they're equal, then you return true. That means they're anagrams. Else you return false. And yeah, let's take a run on these. And as you can see, A, B, C, D, B, C, D, A, they are anagrams. I mean, in the example, I had another A here that's removed. And you can do it for pretty random strings. I just tried a lot of random strings here. But yeah, so that was it. Um, these are the two questions I thought we could work on, and if there was some other time, there was leftover time, we could discuss another question or so, but I don't think we have that. But yeah, but basically there are 4 questions in all, and feel free to go through problem 3. So problem 3 would discuss um, like, I'll just go over the questions. I'll not discuss the solution more, but just or give a high level of the solution. So what you're supposed to do is you're printing all prime numbers less than equal to 10. In the previous problem 1, all you were doing was you're deciding whether 10 was prime or composite. But now your function output will look like something like 2, 3, 5, 7. That means all primes less than equal to 10. And there are 2 methods to go about it. One is the brute force method, which is you go over each number less than 10 and check whether they're prime or composite. And as you can see here, when I give it a very big number like 1 million, it kind of takes 33 seconds to run, which is pretty bad. Because if you think about like engineering applications, 1 million might not even be a very big number there, and it takes 33 seconds, which is a lot. But now we're going to use a smarter algorithm for counting that. You can take a look at it on this Geek for Geeks site, and the same 1 million takes like 0.05 seconds, which is amazing. And I highly encourage you guys to take a look at this question. And the fourth one is another way of how we can make our code more efficient. And um, this is the question where you have a string and you want to find all pairs of anagrams of it in all substrings that are anagrams. So for example, if you have the string AA, BB, BAA, so you have this AA and this AA as anagrams, and there is AB and BA, which are anagrams. And there is a brute force method to do it, and there is um, so as you can see in the brute force, I have defined 3 functions, um, and this one. But if I use and if you can see, like for a very long string, it kind of takes 0.5 seconds, which is kind of okay, but it's still a lot. But if I use an inbuilt function, then you can see that all those 3 functions here got reduced to just 2 lines of code. And so did the time. So the time is for the same string is 0.05 seconds. So this basically tells us that there is always an efficient way of doing things, and in case your code is taking a lot of time, I would highly recommend you guys to look up Stack Overflow or some solution of how to do it more efficiently. And with that, uh, um, I think we are almost at the end of the Python workshop with just our work, showcasing our work left over. And I think, yeah, Sahil can share the slides and we could discuss about that as well very quickly.
I think since there are only 3 people, I hope you guys are all fine with running like 5 or 6 minutes late. If that's okay, just give me a comment. I have a really dedicated audience.
Yeah. Oh.
Okay, I think the first part of how we are using Python in our research will be like how Alrick is using Python in his really cool robotic applications. So this is a video, I think for his thesis. So I think I'll just run this and he'll explain you guys on what's happening.
Yeah, so basically, I use Python to run this simulator called Mojoko. And as you can see, all of this is kind of, um, it's designed in another language, but it's spawned, or how to, um, Python kind of controls what's kind of happening here, and which is very powerful because you're controlling a C-based simulator, which is Mojoko, using Python. And since Python is very easy to code, it makes things very much simpler. And as you can see, this is my experiment setup where there's this car which is pushing a block, and the block is not supposed to leave the inner square. So whenever it leaves the inner square, it's respawning. And yeah, that's pretty much it. But what we're trying to do with it is like, uh, we'll be designing neural nets controllers for this. Uh, so the goal is that the car needs to push a block into a given position and orientation. And right now, this is just a simple push forward controller. There is no neural net controller working right now. But this is my experiment setup. And yeah, that's pretty much it.
Yeah, that's actually like pretty cool.
Thanks, Sahil.
Okay, so this is a part of my thesis. So as Christian has introduced me, I work on using Python to solve problems in turbulence and fluid mechanics in general. So coherent structures like hairpin vertex structures, they join together and form hairpin packets. These are the elementary structures which are basically responsible for generating turbulence. Identifying these coherent structures can be done by hand, but we need to know the velocity at which these coherent structures move in the fluid. If the velocity is not known, then this process becomes extremely laborious. So, in order to identify like all these structures which are present in different scales and sizes, it is really impractical to do it manually. So we use Python to automate and study the properties of these structures, specifically in turbulent boundary layer flows. So if we have a boundary layer flow, which looks something like this, we apply a threshold and a gamma 2 function to identify coherent structures. Once we have this, we basically put a bounding box around it and extract the vortex properties. So if you want to like learn more about this project, or you want to just see what's happening like behind coherent structure research, I have also added the GitHub link. And this is the second part of my thesis, where we know that turbulence evolves on different scales. So it can be really hard to capture all the scales, like the large scale fluid simulations and the really small scale simulations up to the viscosity. So if we were to do numerical simulations using calculations and computations, we would need like extremely fine grids and a huge computational resource to calculate and solve, like resolve all these scales in different scales. On the other hand, if you were to capture them experimentally, it will be really expensive because we need to use these really high resolution cameras and probably do something like PIV or probing or something like that. So our plan is to see if by observing a small scale or a large scale fluid data, can we reconstruct the scales? So for starters, we began by taking a low resolution input, which looks like really zoomed out or extremely zoomed in. And we want to capture the fundamental scales which are present inside the flow in order to capture like most scales which are present in the turbulent flow. I think this is really interesting, and it looks like it's out of a spy movie or something, where you can basically increase the resolution of a picture. So yeah, if you are so we basically use machine learning to get from here to here. Like all the code to do these things are also available in this GitHub thing. If you want to check it, like these are a bunch of resources which. Yeah,
hey,
Christian.
Sahil. Yeah, I had a question. I was watching a TV show where they took an image, like just a kind of low resolution image, and they're trying to figure out, I don't know, it was just kind of like a detective show.
Oh, exactly. They are working on the same things. They are using some
Yeah.
super resolution algorithm.
Well, they saw a glass in the background, and they wanted to check for fingerprints on the glass in the background. So you're saying that with something like this, they could actually do that, and that's kind of what you're trying to do. Take larger data or less resolution data sets and increase the granularity of them using machine learning.
Yeah, exactly. I think the difference in like any natural image, like a fingerprint, or like if you had traffic cameras and they were trying to look at the number plate of a vehicle, it would actually be pretty difficult because they are not governed by any equations like images, right? But if you had like a fluid flow, we know that this is governed by these equations called the Navier-Stokes equations. So we actually have like much more knowledge on the physics behind how these images are like evolved. So we have a slight advantage at doing this for fluids than like random images, but it is still like highly possible to do it for anything. They're actually using a lot of these techniques for video games, where they basically simulate things in a really low resolution grid because it's cheaper to simulate them like real time, and then they use some machine learning to enhance the resolution. Yeah, but that was really interesting to see that they're doing this in some TV shows.
Really cool. Sorry for interrupting. We probably should wrap up soon. We're already 6 minutes over.
Yeah, so these are a bunch of resources which we had in the end. Okay, so as a last takeaway, just check this book out by Jake Vanderplas. This is a comprehensive review of the whole language. Check out the Project Euler website to practice coding in Python, and also check out the Python meme page in Reddit, which will get you motivated to pursue Python because you can understand more memes, as Alrick said. So yeah, I think that'll be all.
Do you guys have any specific questions? Because oh yeah, because we saw a lot of Google form um, requests for the workshop, and we couldn't uh, add so many of them. But do you guys have any specific questions that we can try to answer?
I was just going to ask a question about the, like when I work in MATLAB, I'm not particularly great at anything. So I spend a lot of time on like the MathWorks website, looking up functions and stuff. Is there some sort of equivalent for Python?
Yeah, it's actually Stack Overflow. So
Yeah,
Oh, really?
this one.
you will
Like the
it's so
first resource which we have.
yeah. So it's basically I think I even me and Sahil both visit Stack Overflow every day because we always get into some problem. But the good thing is since Python was like very old and it's like since 1991, it has a huge community and it's like it's definitely someone has tried what you have been doing and there's definitely someone who's asked this question and someone who's answered it. So that's a pretty good thing. So you don't have to like uh, put up your question and wait for weeks for someone to answer. Someone has already properly asked the question.
All right, cool.
Yeah, I think that's it.
All right. Thanks, guys.
Yeah,
Thank you,
thanks for
everybody.
attending. Yeah.
Thank you.
Thank you.
Thanks, everyone. All right. Here, let me stop recording.
Yeah.